All right, so yeah, so in the last session we talked about the introduction to the Azure Site Recovery service, what Azure Site Recovery is all about it, and what capabilities it has, and what you can achieve with the Azure Site Recovery. So um, what are the problems or challenges that every enterprise organization is facing with respect to the business continuity and disaster recovery problems, and how ASR is going to help us. So to show you guys the end-to-end demo, so I've come up with the a lab plan, so which I'm gonna first of all gonna explain you the architecture. Then I'm going to show you how I did set up the environment. Then I will show you what are the different stages we have with respect to the replication, and I will walk you through each and every stage. All right. So first of all, let me explain you the architecture. So this is the sample architecture, what you can see here. So a customer is trying to access the application or a URL, which is basically hosted in the Azure virtual machines. So these virtual machines are hosted currently on West Europe location, and they are part of one specific resource group, which is in West Europe. And these virtual machines are part of a subnet, and their inbound and outbound access is being controlled through the network security group. And this subnet is part of a VNet, which is a production virtual network. And so these two servers, I have installed the IaaS service, and I got the default web page, so that I don't need to show you the real application, but at least I can simulate this one. So to provide high availability, I kept these two virtual machines in the availability set, so that at least one virtual machine is going to be available during the planned maintenance or unexpected downtime situations at Microsoft. So these two VMs are behind the load balancer. So in this case, I've taken external load balancer, but in generally any application server, web server, we do not expose to the internet, and we do not put it behind the external load balancer. We'll try to keep it behind the internal load balancer. So when you keep the internal load balancer, that has to be behind again a firewall system. So in this case, I don't have any firewall system. Just to show you the labs, I have implemented the external load balancer. So since this is like, we will try to do the testing with the load balancer IP address. We'll try to browse the web page that is hosted in this virtual machines and see whether the traffic is being distributed or not. So this is specific to the within the region, within the one specific region, how you ensure that your virtual machines are highly available. And if you look at this, these are the disks of each and every virtual machine that you have it. So to provide the regional level outages, solution high availability solutions during the region level outages. So what I'm going to do is I'm going to keep this load balancer behind the traffic manager. The traffic manager works on a layer 7. It works on a DNS layer. So it is not specific to one region. It is globally available. In case if any user is requesting for website or application access, they reach out to the traffic manager URL, or if you have a custom URL that is pointing to your domain provider, that can also point to this traffic manager. So you can either way configure, either you use your own domain, or you can let your application team or user to use the traffic manager URL. So when user hit this URL, the request goes to the traffic manager. Here I'm going to set this is my primary region, and North Europe is going to be my secondary region. So which means, so this works on a priority basis. So always traffic goes to the primary region, which is West Europe. So in West Europe, you have the load balancer. The traffic goes to the load balancer. From there, it reaches to the backend virtual machines. So whichever the VM is available, it is going to respond to this query. All right. So, but in case if there is a regional outages, we want to ensure that the traffic is routed to the secondary location, which is the load balancer available in the secondary region. Okay. So that is the concept behind this entire setup. And during the failover, during the outages, what we do is we will failover these machines to the target location. So that is when the virtual machines get started created. So when the virtual machines are getting started created, they will be automatically added to the load balancer, and the traffic will, when the traffic is routing to this load balancer, the load balancer will route the traffic to this one of the available machine during the regional outages. So to have this solution automated, what we need to do is we need to set up this load balancer and resource groups and VNet and subnet, as well as the network security groups in advance. In case if you have any route table or any other configuration that has to be in place as per your network architecture or design, you have to keep them in advance. Except the virtual machines, we have to keep everything in advance, so that during the failover outages, it will be easy for us to bring up the services online to the customer. Otherwise, it has to go through a lot of approaches, or it has to go through a lot of changes. See, then since it is two servers, that is totally fine. But when it comes to the real DR situations, in a specific region, you might have, like, say, 1,000 virtual machines, or 5,000 virtual machines as well. Depends on the workloads that you have it. So providing DR solution for them, and creating this load balancer during the DR time or regional outages is going to be difficult. That's why we have to plan this when you are setting up these resources in the first place. Okay, so how this all can happen is, with the help of the Azure Site Recovery. So when you add your virtual machines to the Azure Site Recovery, so Azure Site Recovery is going to install an agent, which is a mobility service agent. Mobility service agent has the capabilities to read the data on each disk of your virtual machine and replicate them to the target ASR replica disk. So this ASR replica disk, you don't need to create anything manually. So this will be created automatically, during the replication process by ASR. So whatever the changes that are making in the disk of your virtual machine will be replicated to the target ASR replica disk. Okay, so during the failover process, ASR is going to use the data in this disk, and it's going to create a new disk, and out of the new disk, it's going to create virtual machines for us. So that is the end-to-end process that's going to happen. And during this process, you will come across a cache storage account. If you're enabling replication from, let's say, West Europe to North Europe, so there will be one storage account that it will be created in the source location, which is basically used for tracking the replication changes. Before this data replicated to the target replica disk, the data goes to the cache storage account. From there, it is reaches to the ASR replica disk. That is how it is going to happen. So, and the reason I mentioned another storage account here is, when you do a reverse replication from North Europe to West Europe, so that is when again you need a cache storage account in the specific location to track these changes. Whatever the changes happening in the source disk, it has to maintain in a specific location. So with that, you are going to avoid the performance issues on your virtual machines. Okay, so that's the reason we have to introduce the cache storage account. All right, so what I've done is I've done entire setup. I'm ready with almost all the configuration, which I'm going to walk you through each and everything now. So I'm going to explain you the architecture, or I'm going to explain you the resources that I deployed. Then later I'm going to show you how to perform the enable replication job, and how to perform the failover, and how to perform the reprotect, and how to do the failback. So the end-to-end lab or an end-to-end implementation we are going to do now. Okay, so as I mentioned, I'm going to take you to the Azure portal to explain you the the environment. So you can look at here, there are 4 virtual machines which are in West Europe location. This is my primary region. There is one virtual machine which is in a stop status because I did a failover. Just to show you guys, I've did a failover, and I will show you why I have done the failover in advance. So consider, like, there are 3 virtual machines now. Okay, and these virtual machines are part of the availability set. So if I go to the availability set, so I'm checking the one which is in West Europe location. This is the one. And if you go here, you can check, you can see there are 4 virtual machines part of the availability set. And if I go to the load balancer, So I have a load balancer, which is in West Europe, WEBELB, that's the name of it. And you can see the backend pool. In the backend pool, there are 4 virtual machines. Okay, there are 4 virtual machines in the backend pool. There's one, you can just ignore it for now. Okay, so which means if I access the IP address of this load balancer from the internet, okay, it should give me the access to the one of the backend server. Right now it is giving access to the from the web01. If I keep on doing it, so I think it might go for the another one as well. Yeah, so you can assume here, you can look at this, right? It's not giving the fully qualified domain name because the script which I've used to install the web service and configure the IaaS actually do not take the more name. I mean, it's the VM name is like 0102, right? So the web page, it is showing up to 0 only. So basically this is automatically routing the traffic to the backend instances. So whatever the missions you see in the backend, so those missions are the traffic automatically being distributed. So how this works is, and how you can create a load balancer is, so you can go to load balancer, click on create here, and provide a subscription, provide the research group, provide the name. So in this case, I've given ELB external load balancer. It's a web. Okay. Select the location where you want to deploy this load balancer. Select the SKU type and select the public or internal. So as I said in the beginning, I don't have any firewall system or any gateway in between, so I'm choosing the public at the moment. So you can go with the regional or global tier. It all depends on the requirement, but I always go with the regional. And because global is something recently introduced, I'm not sure how many capabilities it has, and how much how comfortable it is, to avoid any bugs. So the next thing what you have to do is you have to add the front-end IP address. Since it is being the external load balancer, you need to add the public IP address for this. So provide the name for your public IP, front-end IP. Let's say ELB config, that's a configuration name, and you have to create the public IP. So I'm gonna say ELB public IP address. It's gonna be no zone, and click on add here. The next thing what you have to do is add the backend pool. So you are going to create a pool. Let's say this is going to hold the web servers. I'm going to say web pool, and select the virtual network where your virtual machines are exist. So my virtual machines are exist here. Click on add here, and it will show you all the virtual machines that can be added or part of this backend pool. Click save here. Then you can say click on create, review and create. It's going to create a load balancer with the backend pool that I've created. So since I already created one, so I don't want to go through the steps again. So I'm going to the load balancer once again here. So just to show you the options, front-end IP is something that I just talked about it. Backend pool also we discussed about it. Health probe is something is very, very important. If I go back to the diagram, so health probe basically checks whether the target VM is available on a port that you have specified in the probe. It keeps on pinging to the server on the service that you specified or port that you specified. So if it is available, it respond to the VM respond to the load balancer, and the load balancer will route the traffic to this machine. If it is not available, maybe the server is not responding to the load balancer ping, so it routes the traffic to another available server, and it will not leave it like that. It keeps on pinging after some time again. So that's how the load balancer works here. So that's what I'm specified here. No, I don't want to go for a 443 because it needs certificate, and also I chosen the 80 for now, port 80, as a default website can run on the port 80. So there's something called load balancer rule. So if you click on the load balancer rule, you provide the name of the load balancer rule. I've given ELB rule HTTP, and front-end IP how to select, and what is a backend pool, what protocol it is, what port you're trying to communicate, right? And what is a health probe. So basically the load balancer works on a phi-tuple algorithm based on the source IP and source port, destination IP and destination port and protocol. The load balancer distribute the traffic. So this rule is very important. It will make you understand how this load balancer works. So since these servers are going to be part of a ASR, so during this enable replication job, so you might see the HTTPS traffic goes over the load balancer. So that's why I added an outbound rule where I'm allowing the 443 traffic on the backend pool. So whichever the mission is part of this backend pool will have the 443 communication passed or allowed. So there is one more rule I've created, which is for RDP. So basically I did not enable the public IP, or I did not enable 3389 port on my virtual machines. So I want to take, if I want to take RDP, I'm going to use the load balancer public IP to take RDP to one of the backend server. So for that, what I've done is I've created a NAT rule. So the NAT rule I mentioned backend pool as a web pool. You can also specify, type as Azure Virtual Machine, where you're going to specify the VM name. So I've chosen backend pool, and if somebody is requesting RD connection to this public IP or front-end IP address, and the port, if they are requesting on 3389, or I can say 3390 also, this is a front-end IP port, right? And if the backend port also is 3389, so it has to route the traffic to the whichever the server that is available in the backend. So whichever is available. So when you take right now, it might go to the 01. When you take after some time, that RDP connection might goes to 02 or 03 or 04. So whichever the server is available, so during that time it's gonna connect. So that's about the NAT rule. So I've fully utilized the load balancer here to distribute the traffic to the backend instances in a specific region, and also to take RDP to the servers without exposing their information to the internet. So that's how I did set up the load balancer. I hope you all got some clarity about this. I have set up the high availability in a one specific region. So let us do a quick test. I think we already did a test as well, right? We tried accessing the website through load balancer IP address, and it was able to give us the response from the backend instances. So that is also done, right? So one thing that I missed to show you guys, how I install the IAS. So it's pretty straightforward and pretty easy. So we have a PowerShell command, basically that will enable the IAS automatically. So this is the script that I have used it. And if you go to the Microsoft documentation, configure the Azure load balancer, that has the script as well. So what you need to do is you just need to go to the virtual machines. Let's say if I go to the virtual machine and go to the run command, run PowerShell script here and put it here and run it, it's going to install the IAS service automatically. So you don't need to configure, log into the server, enable IAS from the server manager. Without logging into the server, you can do all these things. Since we are not application experts and we are not a code development experts at the moment, so I just use a sample website to show you guys. Okay, so now since we talked about the source environment, and we are going to enable the replication, so let me show you what are the target resources I have created. Okay, so what I will do is I will go to first I will show you virtual networks. First, I will show you the resource groups first. So I'm going to select everything into North Europe location. That's our target DR location, right? So this is the resource group what I've created for the replication. And in the target, you can see I'll sort it by type. So I created one availability set in advance, and ASR also creates one availability set. And you can see there are ASR replica disks created for each virtual machines. So this is the one which gets created when you enable the replication. I will show you in a moment. We'll talk about it. And you can also see there is one load balancer which I created, and there's one network security group I created. Okay, and since I enable the load balancer, definitely we need a public IP address. This is a public IP address I've created. Okay, and you also need a virtual network. You see the virtual machine and network interface card, right? Basically, I did a failover. So that's the reason the virtual machine is failover to the target location, which is North Europe. The one which you see earlier as in a stop status. So that is the one which is replicated here when I did a failover. Okay, so this is how the setup is completed. If I go back to the load balancer in the North Europe location, you can see the front end IP is there, and backend pool is there, but it is empty. There are no virtual machines, right? So post failover, we are going to add virtual machines to this backend pool automatically, manually. You can also automate this process by creating a PowerShell script and keeping them in the automation runbook and use the recovery plans. I'm going to show you where to use these automation scripts in the while performing the failover. And health probes, I have it, but I haven't created. Let me create one health probe. Let's say HTTP probe, and this is in North Europe. So we are creating a health probe. Then we'll also create a load balancer rule so that, as soon as you're done with the failover, the traffic goes to the load balancer and load balancer knows where to route the traffic. Okay, so today we are just going to add these machines manually to this load balancer, but otherwise, if you use a script, these machines automatically added, and even the energies also can be automatically added. Okay. So this is good. And I go to the load balancer rule, click on a rule. So ELB hyphen rule hyphen, let's say this is a E1, right? Europe North. It's a front end IP. This is a backend pool, but there are no members inside the backend pool. And port number is 80. And in the backend port also, I'm going to say 80. And health probe I just created. I'm going to create this load balancer rule. Okay, so one more thing we have to do it if you want to do a reprotect. So this load balancer should also have the outbound rule with for the port 443 has to be enabled. So let me check. I think I already enabled it. Yeah, you can see even here also I already enabled the HTTPS port. So I did not enable the NAT rules. I don't want to do this. It's not required, right? Because we're just doing the failover and reprotect and failback. Okay, so this is the entire setup. I think the complete picture you might have got it. So what I'm going to show you right now is I'm going to show you the recovery service part. Okay, and okay, before I go there, I want to show you this part, traffic manager profile. Okay, so if I go back to the load balance traffic managers. So this is a traffic manager profile which I created. If you want to create a traffic manager for your lab, just click on create here. So provide the name for your traffic manager profile. Let's say test. So there are different routing methods. You have performance-based, weighted-based, priority-based, geographic, multi-value, and subnet. Depends on your routing situation, you can choose the one. So most of the customers might go for the priority based if it's a DR situations, and otherwise they can also go for the performance based or weighted. So if you have a multi-tier architecture, maybe you can go with this multi-value. And if you want to route the traffic specific based on the geographic location, let's say if there are any employees working trying to accessing any application from the UK, so the request will be routed to the nearest endpoint for the specific geographic location. So it will only route the request to the UK. So though there is an endpoint available in US, any other region, maybe you can specifically say, okay, any request coming, so it has to go to a UK or US. You can specify the geographic, and based on that, it will route the traffic. And performance, basically, it name itself says, right, to simply explain, it will reduce the network latency, which means you have multiple endpoints, right? And multiple backend instances. So it will try to route the traffic to the nearest one for your user's location. So user is accessing from India location, the traffic automatically routed to the nearest, endpoint, so that the network latency is less, so that performance is better, right? So weighted, you're going to specify the weights. So based on the weights that you're specifying, the traffic will be routed. So likewise, priorities, like you set the primary and secondary location. So in this case, we are setting up West Europe as a primary and North Europe as a secondary location. So if I go back to this, this is a profile which I created. So you can see here, one is online, the other one is degraded. So the one which you see here, let's say I'll go to endpoints, right? This will give you some detailed view. So you can see Europe West external load balancer is online. Europe North external load balancer is degraded because the traffic is currently going to the primary one. And moreover, it usually says online if there is a service that is responding in the backend. Yes, obviously, this load balancer is routing the traffic. This traffic manager is routing the traffic to the load balancer, which is in a North Europe location. But that load balancer has an empty backend pool, so it doesn't have any members. That is the reason you see the status has degraded. Otherwise, it could have been says online. Both are online, but always traffic will be routed based on the priority that we set. Minimum priority is 1, right? It goes to this one, and if it is not responding, automatically the traffic has to go to the secondary one. So during the during the failover situations, real DR situations, what happens is the primary won't be responding, so this will be degraded. And if you don't perform the failover, this will be degraded. Both will be degraded status. So what you do is you do a failover when this is degraded, when the primary region is down. When you fail over, the VMs will be failed over to the DR location. The VMs will be added to the backend load balancer, and this will come online. So all the traffic should goes to this secondary region load balancer. All right, that's how it's going to work. And that's how I added. How I added is just click on add here, add endpoints. So I'm choosing Azure endpoint. You can also choose external load by endpoints and nested endpoint as well. Okay. So external endpoint is something like, you have a, load balancer. Maybe you have some device which is outside of the cloud and Azure environment, that we say external endpoint. So nested endpoint is like, you already have a traffic manager profile. So within the traffic manager profile, you're going to create another endpoint. So you're going to route the traffic to the another traffic manager profile endpoint. That's called nested endpoint. Okay. So here I've chosen the public IP address, public IP address of my load balancers. That's where it was showing up here, and I created it. Okay. So now I think you got clarity about this entire stuff. So traffic manager also is good. We're done with it. So now let's enable the replication. So to enable the replication, I have created a recovery service vault here, which is in an east to west location. So basically the recovery service vault location and the resource group should not be same as your VM's resource group and VM's location. Okay, it should be different. The reason because during the outages situation, if the recovery is involved and the VM is in the same location, you cannot perform the failover. That is the reason Microsoft made this condition. You cannot have both in the same region. So for that, I've created a recovery service vault in the east west location. So I have already enabled replication for a couple of servers, but just to show you guys, I have one server that is left. So what I am going to do is, so I'm going to perform various steps now. Okay, just to give you more clarity and to avoid any confusion. So what I'm going to do is, the first thing is that I'm going to enable replication for one of the virtual machine. Okay, one VM which is in a West Europe location. Okay, so this job might take some time. Okay, this job might take some time. So what I have done is I already enabled replication for a few virtual machines. I am going to show you after the enable replication job is completed, how it is going to looks like. Like I'm going to show you RPO values, and I'm going to show you recovery points and various other stuff. Okay, this is the second step. Like once enable replication job is completed, this is the second step. You will see the VMS like this. Okay, so once you have the RPO and all, so we have to enable the replication, we have to enable the failover. So I'm going to perform the failover because I already enabled replication for few machines, so we already have the virtual machines ready, and I can perform the failover. So which means after you enable replication, if you perform the failover, how it is going to be, I'm going to show you. Okay, so which means the VMs will be in a target location, which is in a North Europe location, and they will be up and running. So that is what we are going to expect it, right? So later, if you want to move them back to the primary location, which is basically a process called reprotect. Okay, we say this is a reprotect. So reprotect is nothing but it is same as your enable replication job. So basically it is going to replicate the data to the primary region. Okay, since these machines might be running in couple of days in the DR location, there could be sometimes the data might be updated here to synchronize those changes, right? It might take some time. During the enable replication job, we say the first process is IR, initial replication, then it goes to the delta replication, right? So here it's the same process. Instead of IR, it is, we are going to say synchronization. So it's going to synchronize the data from DR location disks to and the primary location. So whatever the changes happen when the servers are in DR location, those changes are going to be replicated to the primary location. So this is called synchronous process, and this process may take time. It may not be the same duration as your initial replication when you enable replication, right? It is almost same, but not exactly the same time it's going to take. So we will fail over and we'll initiate the reprotect. So I already initiated reprotect for one of the server, and I will show you after the reprotect how I am going to do the failback. Failback is nothing but we are going to do the failover from DR location to the primary location again. So eventually the VM is going to be running in the primary location. It's like end-to-end DR process that we are going to implement it. Okay, so going back to the virtual machines, and the virtual machine which I'm going to use it here is the 04. So the 02, I already implemented failover and reprotected. So I will show you at the last, and 01 and 02, I believe I'm going to, not 02. Okay, 03. 03, I'm going to show you how to perform the failover. So let me go to recovery service vault first. Okay, so before I go, guys, I want to show you one more thing. So we did implemented the traffic manager profile. So as per the current setup, if I am trying to browse the traffic manager profile, the request has to be routed to the West Europe servers, right? West Europe servers application. So I'm going to click on this one. I get the URL here and try to browse it here. It's giving a response from the backend instances. The traffic is going to the load balancer of West Europe, and from there it is trying to reach to the backend instances, and it's giving us a response. Okay, now let's go to the recovery service vault, DRRSV, and here I'm going to click on site recovery and select enable replication for Azure virtual machines. Select the location where your virtual machines are exist. Select the subscription where your virtual machines are exist. This is basically a source information that you are going to choose it. And select the resource group where your virtual machines are exist. Click on next. And you see there's one virtual machine that is being discovered. So I think it's not 04, it is 03, my bad. Okay, so I'm selecting the 03 server, which can be enabled replication. Click next here. The next one is to select the replication settings. What is the target location? So in this case, I'm going to choose the target location as North Europe. And here, what is the resource group? This is going to be my resource group, which is in a North Europe location. And what is a VNet? You can select the existing VNet, or if you want to create a new VNet, you can create. So which means post failover, the virtual machine will be part of this subscription and resource group, VNet and subnet. Okay, so we need a cache storage account to enable the replication. So basically, if you already have one, you'll be able to choose them here. So here you can see if you want to exclude any specific disk, you can exclude it. So this is the one, this VM has one disk, and you see respected replica disk is going to be created. You can choose whether target replica disk as a premium SSD or standard SSD or standard HDD. Depends on your situation, you can choose it. But I always suggest, though you have the source machine as premium SSD, you can always go for the standard HDD because it won't impact the performance of your disk. Okay, so you can also specify, what is the churn rate and all. The disk you are going to, the disk which you chosen, what is the churn rate, like, how much data is going to write on the disk, how quickly it writes the data. So based on that, they're going to specify the infrastructure. So disk we have chosen, and if you want to choose the availability sets, you can choose the availability sets and select here, click OK, and click next here. And so basically, as I mentioned, during the replication process, ASR is going to install the mobility service agent, and that agent Microsoft keep on updating every monthly or quarterly. So whenever they introduce the new agent, if you want to ensure that the agent is up to date, so you have to choose the allow ASR to manage. Otherwise, you can take a decision like, when there is a new update or new agent version is available, you can install them manually. So two options you have it. So I'll go with the manage manually. Otherwise, it creates a new automation account for us. Okay. And I was talking about the replication policy. I'm choosing the existing replication policy here. Click on create new, provide the policy name, and provide how long you want this to be retained. I think they are giving I think 15 days, which is really good, right? So I'm gonna say 1 day. And I was talking yesterday in the last session. So crash consistency recovery point will be generated for every 5 minutes, and it is pruned after an hour. Okay, if you want to enable the application consistency recovery point, you can enable it. You can specify how frequently you want to enable, 1 hour or 4 hours as such. So based on this, the application consistency recovery point will be generated. I'm going to click OK. Now I'm not going to click anything because I already created one replication policy. So next, click on next here and enable replication. This is how you add your virtual machines to the recovery service vault for configuring the replication. So once you enable replication, what happens is you can go to the jobs here, site recovery jobs. I already enabled for few machines, which I'm going to show you. Okay, so there are many steps it goes through it, but I'll show you this one. Enable replication job, you can see here, right? So I'll take this one. Okay, so there are prerequisites. It's check whether virtual machine is compatible or not for the replication. And this is where you're gonna see, right, installing mobility service agent. And you see this is taking more time. Okay, so usually this process takes time, and once the agent is installed, enable replication job will be completed, and later immediately it will start the IR, initial replication. Once the initial replication is completed, it will update the everything, all the status and state of your protection status of your virtual machine. Then it will say enable replication successfully completed, and you have the initial replication completed, you have the replication RPO values available, and protection status available. So when this state is completed, how it is going to look, I'm going to show you now. Okay, because I already did for a couple of machines. So I'm going to the site recovery replicated items here. In the replicate items, you can see the first one is in enable replication stage. We just enable the replication, and you can see it's following the same step that I was talking, installing the mobility service agent and preparing the target. So this is at the stage. We'll ignore that, and if you want to check this, you can go here. As soon as enable replication job is completed and production is enabled, or initial replication is completed, the status shows as protected, and replication health is going to be healthy. So click on this one, and you will see as this, status protected and RPO, recovery point object, right? So if you perform the failover, right, example, right, whatever the data is written 2 minutes ago, you're not going to get it. It's going to be lost. If it says 1 hour, since 1 hour the replication is not happening properly, right? If you perform the failover, you can go back to last 1 hour data and initiate a failover, which means last 1 hour data you can use it and bring up your environment to the target location, that is RPO, right? How much data loss you can expect here, that's what this RPO means, right? So if it is going beyond, then it's going to be a problem, right? The replication status will say critical and all. And you see the agent version, this is nothing but your mobility service agent version. And you can, if you want to understand the replication flow, you can see virtual machine sending its metadata information to the site recovery, and virtual machine data is being replicated to the cache storage account. This is where it's in West Europe location. This is where it's going to perform all the checksums and file validations. Then it's going to replicate the data to the target ASR replica disk. That's what is going to happen. When you do a failback from North Europe to West Europe, the diagram will change and it will be in a quite opposite way. Okay, so that's about it. And if you check the latest recovery points, you can see there are recovery points available. Okay, and you have a test failover option. When you click on test failover, it's going to create a test virtual machines in the network that you're specifying it, and you can log into the test machines and perform your validations, like, VM application is working fine, and the data is consistency is available, you don't see any data loss, kind of things you can specify it. But otherwise you can go ahead and do the failover option as well. Click on failover as well. So before failover, if you want to modify some values, let's say if you go to compute, if you want to change the host name, right? So post failover, I want to ensure that the VM name will be Europe North. Okay, and post failover, I want to keep this VM in a different resource group. I want to give a different VM size. I want to change the availability set, right? So all those things, if you want to modify, you can modify it, right? So let's say if you want to change something on the network side, right? Click on edit here. You want to change the network, you want to change the test failover network, or maybe you want to change some other properties of your virtual machines, network configuration. You want to give the static IP address post failover, you can give that IP information as well here. All right, so this is how you are going to modify any settings for your virtual machine. And if you go to the disk, you can see how much data has been, what is the size of the disk and how much data is pending on the source. And this is what you see, right? This is the ASR replica disk. So this disk information is being replicated to this disk at the moment. And when you do failover, ASR is going to use the data of this disk and going to create a new disk like this and use this disk to create a new virtual machine. If you have any other data disk, you will be able to see them here. Okay, so this is about the properties of your virtual machine, right? And if I go back to the another one, which is I think 04, if I take example here, right? So this one also have only one disk. Okay, if you have more than one disk, you can see that. I think I have 01. I think I already just checked it, right? Okay, let me see this one. This one also have only one. Okay, that's fine. So this is how the replication works. Now I'm taking another scenario. If I want to perform the failover, it is pretty straightforward. I just click on here and perform the failover. Okay, so it says you did not perform the test failover. Are you okay to do it? I say okay. If I do continue play failover, it's going to perform the failover, which means it's going to let me click on this, right? Shut down the virtual machine which is in source location, that is West Europe, and initiate the failover operation. And what recovery point you want to choose it, you can click on custom and specify the which time recovery point you want to choose it and initiate a failover. That is also available. But think about the real-time situations, right? You have an app layer, you have a DB layer, you have the web layer, right? Different layers you have it. So when you have these three different layers, you might say, okay, first of all, let's say DB app and app services has to be powered off. Maybe DB service has to be powered up. Then only you have to power up the application, then power up the web services, then power up the DB server, application server, and web server. There is some sequence that you have to follow when you have a two-tier architecture applications or three-tier architecture applications. And if I do failover for one by one, it's going to take time also, right? So what if you have multiple machines? Let's say you have three web servers, three database servers, and three application servers, and you want to perform the failover for all of them at once, and you want to sequence. You want to keep a sequence so that one after the other one can be powered off, right? If you want to achieve that, and moreover, post failover, you want to perform certain activities. Let's say adding the VMs to the load balancer, adding the VM network security group to the virtual machines post failover, maybe subnet, right? So maybe you want to perform, let's say, post failover, I want to check the application service running or not, restart the application services, restart the DB services. If you want to perform such kind of operations, then this may not be a best solution, right? You have to do, if you see, in this case, you have only 4 machines. Maybe in the enterprise, you might have 10 virtual machines, 50 virtual machines in specific region, and they are production critical, right? So for such kind of things, right, what we do is we use the recovery plan. If I go to the recovery plan, click on the recovery plan, you are going to specify the plan name. Let's say web plan, just example I'm taking. What is the location? West Europe, target is North Europe, and select the resource manager, select item. This is where you're going to specify the number of virtual machines which you want to add to this recovery plan, and click on create. So if it is a real environment, you might see your web layer and DB layer and application layer servers, and you're going to select everything. Then click on create. When you click on create, it's going to create a recovery plan like you see here, prod-plan, and you will see how many machines are available in the source location. And if I do customize here, so this is where you are going to create a groups, group 1, group 2, and group 3. So group 1 you say web servers, and group 2 you can say application servers, group 3 you can say database servers, right? And in group 1 you have something called pre-actions, okay, and post action, which means before the failover you want to perform some operations, or after the failover you want to perform the operation for the group 1, right? You have these options, and you want to add more predictors, you can add. So I'm going to say pre-action here, for example, right? So you have to specify the script. The script has to be located somewhere in Azure Automation account, or you can specify the script manually here. Okay, you perform these steps when the failover is happening or test failover is happening. So if you have a script, let's say in automation account, let's say start app services. Let's say stop app services, right? App services. Then select the automation account. This is the automation account which I created. I will show you quickly. Automation account. See, I'm not going to perform any actions here, okay? You see, this automation account I've created, and I have one managed identity that I've created. You see, this is the managed entity, and I've given the owner permission for this managed entity. Okay, so, and you can select the runbook name. I'm just selecting the one runbook, which is default available. I didn't make any changes, just to show you how is whether it is possible or not. So I'm going just trying to add it here. Okay, so I'm trying to add here. No connection is created in this automation account. So there seems like, there is some procedure you have to follow here. You have to create a connection here, then it should work. Okay, so Azure connection, you have to provide all these things. Yeah, for now let's ignore this. Let's not make it very complex. So but you have an option, if in case if somebody asks you, you have an option, and you have been implementing this one. Okay, so if I want to do the test failover, I can just click on test failover here. Whether it has 10 number of VMs, 50 VMs or 30 VMs, that's totally fine. One click, I'm going to do which is going to initiate the failover. Now I'm initiating the failover for all these virtual machines, and failover direction is from West Europe to North Europe location. So I'm going to shut down the virtual machine before the failover. I'm going to click on OK now. So the failover operation is happening, just assuming that your current West Europe location is down, right? We are going to failover them to North Europe location, and we expect the VMs which are in North Europe is going to be responding to the user's request. Okay, let's see. So this process may take time. Let's give some time and see how it goes. Okay, we can also go to the site recovery jobs and start looking at it. You can see the time, what time it is started, and what operation is going to perform. You see here group 1, group 2, each and every step. So group 2 is going to be performed first, shutting down the virtual machines which is in group 2, and shutting down the virtual machines which are in group 1. That's the next step. Then it's going to start the failover. So then all the steps, one after the other one, it's going to perform. And I believe it's going to take hardly 10 minutes, less than 10 minutes to complete this failover. So we can also go back to the virtual machines and check the status. So I'm going to filter with the West Europe location currently. You can see here it's still running status. So hopefully the 2 virtual machines are going to be powered off. So let's wait, and we'll keep on doing refresh. And I will also open here virtual machines, and I'm going to filter with the North Europe location. Okay, and we'll see. So the VMs has to be created here. So this one is already available because I did a failover a few minutes ago before the call. So let's wait. So whenever I perform the DR in my previous organization, I used to do this way: source location, filter with the customer application, then go to the target location, keep on filtering, keep on refreshing to see whether some changes are happening or not. Okay, so it's still in progress. It's not yet completed. So let's wait for some time. Okay. Yeah, so in my experience, as I mentioned, right, so it usually takes more time when there is a critical situation. So customer environment is down and I need to perform the restart, or perform like stop and start, redeploy. Usually those operations takes around just 2 minutes to 3 minutes. And in such scenarios, when leadership on the call, when everybody on the call, just restart takes around like 10 minutes, 15 minutes. So it's all like, sometimes a bad luck. So this mission, it took 10 minutes, 23 seconds to power off. And the other one is almost started. We did a manual shutdown 10 minutes ago. So it's still in power off status, deallocating. So I'm hoping it will take 2 more minutes to complete. Let's wait for this. Yeah, so we don't know, I mean, usually why it takes. One of the things that you mentioned, it could be because of less capacity. I agree on this part. Any other issues you faced when you're working with respect to the power off, restart, redeploy kind of operations, Karthik?
Redeploy I never tried, but for the power off, for me, sometimes it took like 15, almost like 15 to 20 minutes sometimes. Yeah.
So did you perform any actions during the time, or like is it automatically?
No, sometimes I just try to restart. So even the restart itself, like from the portal, it takes like 15 to 20 minutes, and I try to stop and start. So that also didn't work. So
Yeah, my recommendation is, when this is at this situation, if there is an option to stop it, stop it. Otherwise, you just keep it as it is. Let it complete its operation. The more operations you perform, and the worse it goes. It's okay. Let's wait for a few minutes. for this failover to complete. Yeah. What are the
Yeah.
questions you have while this is
So
happening?
one of the things you have mentioned that while creating the recovery service fault for the DR testing, you mentioned that the recovery service fault should not be in the source region, should not be same as the source region, right? So can it be same as the destination or
Yes, it can be as a destination. That's possible. It will allow to enable replication, but I personally say we shouldn't even allow that, because when you do a reprotect, right, and when you do a reprotect, which means like enabling replication from DR location to primary, and while this replication is happening, what if something happened to the DR location? You cannot perform the failover or failback, right? So that's the reason I recommend to keep the recovery service vault in a separate location. So you basically dealing with three different location in this case. Okay.
yeah, got it?
Okay. Finally, this step two, group to group one operations shutdown is completed. You can see the overall time for this entire group is took around 20 minutes 46 seconds. 10 minutes 23 for one machine, 10 minutes 23 for other machine. It took time for shutdown. Yeah, the reason why it took more time is because it is on a less capacity. The virtual machines are provisioned on the less capacity. You see one virtual CPUs and 1 GB RAM. That's the reason it took some time to shut down the virtual machine. And in the real time, it might also take time because of the application, maybe application service is not responding to power off or stop it. Maybe one of the component is taking time to respond inside the OS or operating system level, so that during that time operate also the failover job might take some more time. So now the failover is in progress. I think this is where the virtual machine is going to be created, and it will be up and running. So now we can go back to the North Europe location and try to refresh this. You can see the virtual machine is being provisioned. You can see it's creating, and once it is created, the status will change to the uh, running, and you can see the naming standard is changed here. EUN. We only modified for one machine. That's this one. I think it is changed. It says Europe North. So let's wait for this. So Europe North mission is created and successfully completed. And there's one more mission which is part of the recovery plan, which is still in a creating stage. But for this, we did not made any changes in the replicate item properties. So we take the same name as a source or original location VM. Okay. So if I go back to the failover job, you can still see failover is successfully completed for one virtual machine. It is completing for another machine now. So once these two steps are completed, it's going to say successful. Now you see the the failover job is successfully completed here. And if you want to check the overall time it took, so it took around 24 minutes, 24 minutes and 15 seconds. So it took 20 minutes for, or I would say 21 minutes for powering off the virtual machines. So the remaining steps, it just took 3 minutes to complete the failover. If the VMs are powered off on time, you don't see the failover is taking more time. Okay. So, but yeah, so in the max to max, it might take 30 minutes to 40 minutes. So it's better to have a more downtime. I don't planned if it is a test DR situations, right? So now failover is completed and two virtual machines are running. And if I go to this web 01, it is part of the availability set. And this one also part of availability set. So now what I will do, I'll go to the load balancers now. And I'll go to the DR load balancer. Go to the backend pool here. Modify this backend pool. Select the virtual network. Click on add IPs, add virtual machines. So we have three virtual machines here. I'm going to select three of them. and click on save here. Okay, once it is saved, I think we should be good to access. And let us also check the network security group, whether we have allowed the required ports or not. Since it is the external load balancer, we should have the communication from the load balancer. So if I go to inbound rule, it has only the default rules. So I'm going to say 443, or it's 80, right? Just allow this rule. And I'm hoping this is associated with our subnet. It's not associated. So I'm going to associate this one. Done. So almost everything is completed here on the setup. And if I go to the networking, you can see the energy associated. These are like post failover checklists that you perform. Energy is right, and availability set is correctly configured. The load balancer is configured properly now. If I go to health probes, you can see everything is automatically configured. And if I go to the load balancing rules, it's also configured successfully. So what we do is we'll go to traffic manager. So I think there's one virtual machine part of this availability set. I'm going to power it off so that entire region is down. So in this situation, the entire West Europe is going to be down. So all the machines which are in North Europe should be active. So we have 3 machines which should actually respond to the traffic manager profile. So I'm going to traffic manager profile now. So this is the one. You see right now both of them are showing degraded. But after some times, the one which is in North Europe should be started responding because everything is properly configured. So I'm going to copy this URL and try to access it. Let's see if it is responding. It's responding basically. This is Europe West, it is showing up. I'll keep on refreshing to see if it is changing to any other machines. Oh, so I'll copy this one, refresh this. Yeah, it's always taking to one machine, but yeah, if we keep on doing it, it might change it. I'm just trying to see if it is giving the Europe North VM response. No, it's taking time. But yeah, you can see, right? So though the primary is down, so request is going to the secondary. But so since we have 3 servers, it is distributing between those servers only. So I will see if I can use any other one browser. Yeah, I'm so unlucky here today. I want to see the traffic is going to Europe North server. Yeah, but unfortunately it is not showing up because these 2 servers, what you see, right, 02104, they are responding very quickly. Okay, so that's the reason, we are not seeing the traffic to 01. So I can just power off these 2 servers to see if the traffic goes to 01. We'll just give it a try. We'll see if the traffic goes to this one. Again, this might take some more time to power off because the VMs are in a low capacity. That's totally fine. Even if it is in a deallocating stage, that's fine because, they won't respond to the load balancer, right? So let us see if I can start doing this now. Let's keep on giving I think it's coming from the cache. Let's keep on giving from the cache. So I'll try something else. Yeah, so we made a mistake here. Our understanding is totally different. Okay, guys, this is actually good. At least you see whatever the name we made changes, right? This is coming from this is what you see is from the uh, Azure layer, but at a host layer, you see still EUW. So unless this changes, right, we can't see the response response being validated from the Europe, West or North. Because when you do a failover, it will have the same host name in the backend. Though you change the name on the Azure site, Azure replicate items, that only to represent the host names from here on the Azure layer, but at a host level, OS level, the host name is not going to be changed. So that's the reason you are saying this. Okay. So, but yeah, eventually, if you understand this, right, the North Europe has come online automatically, right? We just added the machines to the load balancer, and that can be also automated with the process of recovery plans. Okay, so this is the end-to-end DR. We did a failover and we validated and everything is working fine. So we are going to say commit. So when I say commit, what means is, I'll give you an example. If you think the recovery plan, the recovery point which I've chosen while replicating, while failovering is not working fine, I have an option to change the recovery point. So I will have an option to change the recovery point. If I go back to the recovery plans, so I will have an option to change the recovery point. So not here. I think if I go back to 04, this one, right? 01, you have an option to change the recovery point. So if you think that the time recovery point, whatever you have chosen is not good, if you want to change it, you can change it. But if you think the data which we are seeing after the failover is good and we don't see any problem, you can go ahead and click on commit. When you click on commit, what happens is, whatever the recovery points you are seeing here, additional recovery points, right, where you can go back and select them to perform the failover, right? So they will be removed automatically. That is the process of commit. The older recovery points will be removed when you do a commit. So first you have to do commit. After you perform the commit operation, you are going to reprotect the virtual machines. So the another stage which I mentioned, right? We are going to reprotect the virtual machine from DR location to the source location. Once the reprotect is completed, you can perform the failover or failback so that the virtual machine will be back online on the source location. Okay, so once commit is completed, we can do a reprotect. We can initiate a reprotect operation. So let's wait for this to complete. So I have done the reprotect for one of the virtual machines. So if you look at this, the one which is in a North Europe location, active location is North Europe. For this machine, I initiated a commit operation, and I don't see a change recovery point option available. And even if I go to recovery points, I cannot change it because this option is grayed out. Even for these machines, if I go here and I don't have an option to change the recovery point, I only have an option to do a reprotect. So when I do a reprotect, let us do the reprotect from the recovery plan. So click on this one and do a reprotect. So you're reprotecting for multiple virtual machine. Select the target resource group, target win. This is the resource group of your source location, or primary location. We are trying to bring the servers back to the primary location, so to complete this end-to-end DR process. What is the target location, network, and everything you are going to specify it, then click OK. So this process initiate the recovery reprotect operation. So the reprotect operation may take some time. As I said, it's almost same as the initial replication, but almost. But here, instead of doing a complete data replication, it only does the delta replication. You can see for the other machine, web02, I did a commit and I did a reprotect. For me, reprotect took 8 minutes 48 seconds. Sometimes it may take time as well. Okay, so I'm going to show you for this 02 machine. As I said, I already did a reprotect, and now I will have an option to perform the failover. Since the reprotect is completed, that's why you are able to see the recovery plans. So let's do a failover. The failover direction you will see is different now. Failover direction is from North Europe to West Europe. Okay, and I'm going to do the failover. I don't want to shut down the virtual machine because it is taking time. So this is how you perform the end-to-end DR, guys. And so primary to secondary and secondary to primary, whatever the process we perform, I just explained you. And with the real time, at least the sample architecture, you will see the similar architecture when you're performing the failover in the real situations. So the step we have to remember is, what is the concept of ASR, what is Azure Site Recovery, and purpose of Azure Site Recovery, and different operations, different steps you follow when you enable replication, and what are the prerequisites to enable replication, and when you do a failover, what happens, what are the steps it's going to take, and when you do a reprotect, what happens, and how do you do the failback. So before the failover, what are the prerequisites, I mean the steps that you perform, and post failover validations, like we did energy validations, we did a subnet, whether the VMs are deployed in the right subnet or not, right energy or not, right energy associated or not. In case if you have a route table, you just need to check whether route table is properly configured or not. So likewise, if you have application security groups, anything, so every organization maintains a checklist. So whenever they're performing the test DRs, or real DR situations, so they'll maintain a checklist. So usually the different stakeholders, if the server stack is like your application stack and database stack, right? So the application team and database team and Azure team should be coming onto the call, and we say, okay, application validation is completed before the failover, and DB validation is completed, everything is working fine. You will have the operating system team, they also join with you and say, hey, we are good with the OS side as well. That's when you are going to say, hey, Azure side, we are good, we have the latest RPO and latest recovery point, and I'm going to perform the failover. So you're going to perform the failover, and you're going to let them know that failover is completed. You're going to perform the post failover validations. You do your validations from your side and confirm them. Okay, validations are completed, so check your application services, check your DB services, and they will say, hey, everything is working fine, then you're good. If they say that it's not working, then that's where the troubleshooting will start. Okay, why it's not working? Probably the application service is not working properly, maybe it's corrupted. So those kind of things, there's a troubleshooting would start. But otherwise, you mostly do not see any problem from the Microsoft end. Okay, so this is an end-to-end process. I know it's a very lengthy video, but I tried to cover everything that is possible. So I'll try to take one more session where I'm going to talk about the questions and answers, the checklist that we perform, and that will give you some more clarity. Just visit this video once again 2-3 times to get some more clarity, try to implement end to end. So if you have any questions, do let me know. Reach out to me or the WhatsApp, or send an email to me. So I'm happy to respond to you guys. Okay. All right. Thank you so much for everybody for your time.